Hello everyone. In the beginning, please pause the video and review the following problems. After you finish this problem, you can continue the video and I will show you the solution in detail. Okay, let's review this problem together. First problem, 2x plus 3y equal to 16. X equal to 4y minus 3. We try to use substitution method for this problem. Substitution method says we try to substitute one equation into another equation. It looks like we can substitute x directly into the first equation here. So let's directly substitute x. Let's replace this x with the second equation. We have 2 times 4y minus 3 plus 3y equal to 16. I replace this x with the second equation. Then simplify and solve the equation. Distribute 2, I get ay minus 6 plus 3y equal to 16. Then we combine like terms. Ay plus 3y is 11y minus 6 equal to 16. Next, we try to get y by itself. In order to get y by itself, I can add 6 to both sides. On the left side, positive negative 6 can cancel. We get 11y. On the right side, 16 plus 6 is 22. In order to get y by itself, I divide both sides by 11. I get y equal to 2. Next, I need to find x. I can substitute y here and solve for x. Substitute y. Plug in 2 for y and solve for x. X equal to 4 times 2 minus 3. I plug in this 2 for y. Then simplify. 4 times 2 is 8. 8 minus 3 is 5. So for the final answer, we write x, y equal to 5, 2. X coordinate come first and y come after. That's the answer. Number 2. (3x minus y equal to negative 7 and y equal to 2x plus 5. So if I use substitution method, we try to substitute one of the equation into the other equation. I can substitute y, replace y with the second equation. I have 3x minus 2x plus 5 equal to negative 7. Replace y with the second equation. Then simplify. I can distribute negative sign into the parentheses. Make 3x minus 2x minus 5 equal to negative 7. Distribute negative sign into the parentheses. I get negative 2x and negative 5. Then combine like terms. 3x minus 2x. If I combine like terms, 3x minus 2x is 1x. 3x minus 2x is 1x. 1x is the same as x. The rest stays the same. Then we try to get s by itself. I can add 5 to both sides. If I add 5 to both sides on the left side, positive 5, negative 5 can cancel. We get s by itself. On the right side, negative 7 plus positive 5. When we are adding two numbers with different sign, keep the sign from the number that has larger magnitude. Negative 7 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 7 minus 5 is 2. I get x equal to negative 2. Once I know x, I can substitute x here and solve for y. y equal to 2 times negative 2 plus 5. I substitute negative 2 for x, substitute negative 2 for x, then simplify. 2 times negative 2 is negative 4. Keep positive 5 the same. Then combine like terms, negative 4 plus 5. Consider negative 4 plus positive 5. When we are adding two numbers with different sign, keep the sign from the number that has larger magnitude. Here 5 has larger magnitude, so I keep positive 5, keep positive sign. And subtract the magnitude. 5 minus 4 is 1. So x is negative 2, y is positive 1. The final answer, we write x comma y equal to negative 2 comma 1. We must write x coordinate first. For the final answer, we must write x coordinate first and y coordinate after x. That's the answer. Or sometimes we may write answer like this. S equal to negative 2, y equal to 1. That's another way to write answer. And for the first problem, we can write the answer as x equal to 5, y equal to 2. That's another way to write the answer. Number 3. 4x plus 3y equal to 9. X minus y equal to 4. If we try to solve the equation using substitution method, choose one of the equation, solve for one of the variable first. If you cannot substitute directly, you need to choose one of the equation and solve for one of the variables first. Here, in the second equation, it looks like solving for x is easier. So I can choose the second equation, solve for x. In the second equation, if I solve for x, I can add y to both sides. If I want to solve for x, I can add y to both sides. Then on the left side, negative y, positive I can cancel, I can add by itself. On the right side, we have 4 plus y. They cannot be combined, so I leave it the way it is. So first step, you pick one equation, solve for one of the variable first. Then I can substitute x into the first equation. If I substitute x into the first equation, I have 4 times 4 plus y plus 3y equal to 9. Then distribute 4. I have 16 plus 4y plus 3y equal to 9. If I combine like terms, 4y plus 3y is 7y. I get 16 plus 7y equal to 9. Next, in order to get y by itself, I can subtract 16 from both sides. On the left side, positive 16 and negative 16 get cancelled, I get 7y by itself. On the right side, 9 minus 16. Consider we're combining like terms. We have positive 9 and negative 16. When we're combining like terms, follow addition rule. If two numbers has different sign, keep the sign from the number that has larger magnitude. Here, negative 16 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 16 minus 9 is 7. So the answer is negative 7 here. Next, in order to get y by itself, I divide both sides by 7. On the left side, positive 7 get cancelled. We get y by itself. On the right side, negative 7 divided by positive 7. When we dividing two numbers with different sign, answer is negative. 7 divided by 7 is 1. That's y. Next, in order to find x, I substitute y into this equation here. I can solve for x. Substitute y here, I can solve for x. So my x is 4 plus negative 1. 4 plus negative 1. When we adding two numbers with different sign, keeping a sign from the number that has larger magnitude. Here, positive 4 has larger magnitude, so I keep positive sign. Then subtract the magnitude. Subtract the magnitude. 4 minus 1 is 3. So x is positive 3. So the final answer we write as a point. We write x comma y equal to 3 comma negative 1. Or we can write it as x equal to 3, y equal to negative 1. Either way is okay. You can write the answer as a point, or you can write each of them individually. Number 4. 2x plus y equal to 2. 5x minus 4y equal to 18. So if we try to use substitution method, first of all, try to solve one of the equation for one of the variable first. It could be any equation, any variable, whichever is easier for you. If you look at the equation, it looks like in the first equation, solving for y is much easier. In the first equation, solving for y is much easier. We have 2x plus y equal to 2. If I try to solve for y, I can subtract 2x from both sides. Then I can get y by itself. On the left side, positive 2x and negative 2x get cancelled. We get y by itself. On the right side, we have 2 minus 2x. I get y by itself. Next, I can substitute y into the second equation, then solve for x. Since I solved y from the first equation, I substitute the answer into the second equation and solve for x. I have 5x minus 4 times y. Y is 2 minus 2x equal to 18. Then simplify, solve the equation. I can first of all distribute negative 4 into the parentheses. I get 5x minus 8 plus ax. Distribute 4. Negative 4 times 2 is negative 8. Negative 4 times negative 2 is positive 8. Next, I can combine like terms. 5x plus ax is 13x. Leave minus 8 the same. 5x plus ax is 13x. Leave minus 8 the way it is. And putting 18 down. Next, I can subtract a. I can add a to both sides. I want to get s by itself. That means I need to eliminate a first, then eliminate 13. So add a to both sides. On the left side, positive a, negative a get cancel. I get 13x by itself. On the right side, 18 plus a is 26. In order to get x by itself, we divide both sides by 13. On the left side, 13 on the top and bottom get cancelled, we get s by itself. On the right side, 26 divided by 13 is 2. That's the value for x. Next, in order to find y, I substitute x here, solve for y. Substitute x here, solve for y. Y is 2 minus 2 times 2. Substitute x here, solve for y. Negative 2 times 2 is negative 4. Negative 2 times 2 is negative 4. 2 minus 4. Consider combining like terms. Positive 2 plus negative 4. Positive 2 plus negative 4. When we're adding two numbers with different sign, keeping the sign from the number that has larger magnitude. Positive 2 and negative 4. Negative 4 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 4 minus 2 is 2. So the final answer, we can write x comma y equal to 2 comma negative 2. Or we can say that we can write it as x equal to 2, y equal to negative 2. That's an answer. Number 5. Negative 2x plus 3y equal to 14. X minus 4y equal to negative 17. So if we try to use substitution method, choose one of an equation, solve for one of the variable first. It looks like in the second equation, solving for x is easier. So I can pick second equation, solve an equation for x. X minus 4y is negative 17. If I try to solve for x, I need to eliminate 4y. So I add 4y to both sides. If I add 4y to both sides, on the left side, positive 4y and negative 4y can cancel, we get s by itself. On the right side, negative 17 plus 4y, I can write it as 4y minus 17. Usually write the positive term first is easier. Write the positive term first is easier. Here I get x by itself. Then next I can substitute x into this first equation. Since I solve this x from the second equation, when I substitute x into the first equation, I have negative 2 times 4y minus 17 plus 3y equal to 14. I substitute 4y minus 17 for x. Then distribute negative 2. I have negative ay plus 34. Negative 2 times 4y is negative ay. Negative 2 times negative 17, double negative is positive. 2 times 17 is 34. Plus 3y equal to 14. Next, I can try to combine like terms. Negative ay plus 3y. When we adding two numbers with different sign, keep the sign from the number that has larger magnitude. Here, negative a has larger magnitude, so I keep negative sign. Then subtract the magnitude. A minus 3 is 5. I get negative 5y plus 34 equal to 14. Next, in order to get y by itself, I need to eliminate 34 first, then eliminate negative 5. So in order to eliminate 34, I subtract 34 from both sides. On the left side, positive negative 34 can cancel. I get negative 5y by itself. On the right side, positive 14 and negative 34, if I combine like term, keeping the sign from the number that has larger magnitude. Here, negative 34 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 34 minus 14 is 20. In order to get y by itself, I divide both sides by negative 5. So on the left side, negative 5 on the top and the bottom get cancelled. We get y by itself. On the right side, negative 20 divided by negative 5. When we divide two numbers with the same sign, answer is positive. 20 divided by 5 is 4. So y is 4. Once I know y, I can substitute y here and solve for x. Once I know y, substitute y here, I can solve for x. X is 4 times y minus 17. Substitute 4 for y. Replace letter y with number 4. I get 4 times 4 minus 17. 4 times 4 is 16. 16 minus 17 is negative 1. So the final answer, I can write it as sy equal to negative 1 comma 4. Or we can write it as s equal to negative 1, y equal to 4. That's the final answer, or you can write it like this. Number 6. For x minus y equal to 2. X plus 3y equal to 20. So When we try to solve using substitution method, first of all, choose the equation, solve for one of the variable first, whichever is easier. It could be any equation, any variable, whichever is easier. In this problem, in the first equation we have negative y, in the second equation we have positive x. Solving for positive x is easier than solving for negative y. So let's solve for x from the second equation. Second equation is x plus 3y equal to 20. If I try to solve for x, I need to eliminate 3y first. So I can subtract 3y from both sides. Subtract 3y from both sides. On the left side, positive 3y and negative 3y can cancel. We get x by itself. On the right side, we have 20 minus 3y. Here I get x by itself. Next, I can substitute x into the first equation. Since I solved this x from the second equation, when we substitute, we need to substitute into a different equation. So I substitute x into the first equation. I have 4 times 20 minus 3y minus y equal to 2. Next, I can distribute 4 into the parentheses. If I distribute 4 times 20 is 80. Positive 4 times negative 3 is negative 12. Positive 4 times negative 3y is negative 12y. Keep minus y the same, equal to 2. Next, we try to combine like terms. Negative 12y and negative y. If there's no number in the front, consider there's number 1 in the front. Consider this is negative 1y. Negative y is the same as negative 1y. Then if we combine like term, we try to add the coefficients. Follow addition rule. When we're adding two numbers with the same sign, answer is negative. Then we add the magnitude. 12 plus 1 is 13. Y stays the same. When we're adding two numbers with the same sign, keep the sign, add the magnitude, keep a negative sign. 12 plus 1 is 13. Letter y is in the like term, it stays the same. First term, 80 stays the same, equal to 2. Next, in order to get y by itself, we need to eliminate 80 first, then eliminate negative 13. So I can subtract 80 from both sides. On the left side, positive 80 and negative 80 can cancel. We have negative 13y. On the right side, positive 2 and negative 80. When we're adding two numbers with different sign, keep the sign from the number that has larger magnitude, then subtract the magnitude. Negative 80 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 80 minus 2 is 78. In order to get y by itself, next I divide both sides by negative 13. On the left side, negative 13 on the top and the bottom get cancelled, we get y by itself. On the right side, negative 78 divided by negative 13. When we divide two numbers with the same sign, answer is positive. 78 divided by 13 is 6. And that's y. Once I know y, I can substitute y and solve for x. Substitute y, solve for x. S equal to 20 minus 3y. Y is 6. Substitute 6 for y and solve for x. S equal to 20 minus 3 times 6 is 18. 20 minus 18 is 2. So for the final answer, we write s comma y equal to 2 comma 6. Write x first and write y after x. Or we can write the final answer as s equal to 2, y equal to 6. Number 7. X minus 2y equal to 1. 3x plus 2y equal to 11. For number 7, we try to solve this equation using elimination method. For elimination method, we try to add or subtract the equation and try to eliminate one of the variables first. Observe this equation. If I add the equation, x plus 3x is 4x. Negative 2y plus positive 2y get cancelled. On the right side, 1 plus 11 is 12. I have 4x equal to 12. In order to get x by itself, I can divide both sides by 4. On the left side, number 4 on the top and the bottom get cancelled, we get x by itself. On the right side, 12 divided by 4 is 3. So I find x equal to 3. Once I know x equals 3, I substitute x into one of the equation, solve for y. If I substitute x into the second equation, or the first equation is easier, it could be either equation. If I substitute x into the first equation, I have 3 minus 2y equal to 1. Substitute 3 for x. Then we try to get y by itself. In order to get y by itself, I can subtract 3 from both sides. Subtract 3 from both sides. On the left side, we have negative 2y. On the right side, number 1 plus negative 3. Try to combine like terms. When we combine like terms, keep the sign from the number that has larger magnitude. Here, negative 3 has larger magnitude, so I keep negative sign. Then I subtract the magnitude. 3 minus 1 is 2. So negative 2y equal to negative 2. In order to get y by itself, I can divide both sides by negative 2. On the left side, negative 2 on the top and the bottom get cancelled, we get y by itself. On the right side, negative 2 divided by negative 2. Double negative become positive. 2 divided by 2 is 1. So the final answer is sy equal to 3, 1. Or you can write it as s equal to 3, y equal to 1. That's number 7. Number 8. 2x minus 5y equal to 1. X plus 4y equal to 7. For equation number 8, if I add the equation directly, nothing can be cancelled. If I add the equation directly, 2x plus x is 3x. Negative 5y plus 4y, they don't get cancelled. 1 plus 7 is 8. Nothing could be cancelled. None of the variables could be cancelled if I add directly. So for number 8, we need to multiply the equation by some numbers to make coefficient the same but opposite sign. Observe here. If I multiply the second equation by 2, I can make 2x here. If I multiply the second equation by 2, I can make 2x here. Then, in order to have opposite sign, I multiply second equation by negative 2. If I multiply second equation by negative 2, it will be negative 2x here. When I add the equation, positive 2x and negative 2x will be cancelled. So if I multiply the second equation by negative 2, that means I multiply every term by negative 2. I have negative 2x, negative 8y equal to negative 14. If I multiply second equation by negative 2, I have negative 2x, negative 8y, and negative 14. I multiply each term by negative 2. And I leave the first equation the same. If I add the equation, on the left side here, positive 2x and negative 2x get cancelled. And negative 5y and negative 8y. Consider we combining like terms. When we combine like terms, if two numbers have same sign, keep the sign, add the magnitude. 5 plus 8 is 13. And letter y is the like term, it stays the same. On the right side, we try to combine like terms. on the right side. When adding two numbers with different sign, keep the sign from the number that has larger magnitude, then subtract the magnitude. Here, negative 14 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 14 minus 1 is 13. In order to get y by itself, I divide both sides by negative 13. I divide both sides by negative 13. On the left side, negative 13 on the top and the bottom get cancelled. I get y by itself. On the right side, when we divide two numbers with the same sign, answer is positive. 13 divided by 13 is 1. So y is positive 1. Once I know y, I can substitute y into one of these equations and solve for x. I can substitute y into either equation, then solve for x. If I substitute y into the second equation, I have x plus 4 times 1 equal to 7. I substitute 1 for y and solve for x. 4 times 1 is 4. In order to get x by itself, I can subtract 4 from both sides. On the left side, positive 4 and negative 4 get cancelled. We get x by itself. On the right side, try to combine like terms. Positive 7 plus negative 4. When we add in two numbers with different sign, keep the sign from the number that has larger magnitude. Here, positive 7 has larger magnitude, so I keep positive sign. Then subtract the magnitude. 7 minus 4 is 3. So the final answer, x, y equal to 3, 1. Or we can write x equal to 3, y equal to 1. Number 9. 2x minus 3y equal to 7. 5x plus 6y equal to 4. So observe the coefficient here. If I add the equation directly, nothing could be cancelled. If I add it directly, nothing could be cancelled. But if I multiply the first equation by 2, I can make negative 6y here. If I multiply by first equation by 2, I can make negative 6y here. And negative 6y will cancel positive 6y when I add the equation. So let's multiply the first equation by 2. If I multiply the first equation by 2, I can make 4x minus 6y equal to 14. And I leave the second equation the same. 4x plus 6y equal to 4. If I add the coefficient, negative 6y and positive 6y will be cancelled. 4y plus 5y is 9y. 4x plus 5x is 9x. 4x plus 5x is 9x. On the right side, 14 plus 4 is 18. In order to get x by itself, I divide both sides by 9. So on the left side, positive 9, negative 9, on the top and the bottom get cancelled. We get x by itself. On the right side, 18 divided by 9 is 2. That's x. Once we know x, we can substitute x into the first equation or the second equation, solve for y. So let me substitute x into the first equation. I have 2 times 2 minus 3y equal to 7. I substitute 2 for x in the first equation. Then solve the equation for y. 2 times 2 is 4. 4 minus 3y equal to 7. In order to get y by itself, we need to eliminate 4 first, then eliminate negative 3. Subtract 4. On the left side, positive 4, negative 4 can cancel. We have negative 3y by itself. On the right side, 7 minus 4 is 3. In order to get y by itself, I need to divide both sides by negative 3. On the left side, Negative 3 on the top and the bottom get cancelled. We get y by itself. On the right side, positive 3 divided by negative 3. When we divide two numbers with different sign, answer is negative. And 3 divided by 3 is 1. Here we know x and y. So for the final answer, we write x comma y equal to 2 comma negative 1. Or we can write s equal to 2, y equal to 1. Y equal to negative 1. Number 10. 2x plus 7y equal to negative a. Ax minus y equal to 26. For number 10, we have two choices. I can multiply first equation by 4, then I can make ax here. Or I can multiply second equation by 7. If I multiply second equation by 7, I have negative 7y here. That matches the first line. But if I multiply second equation by 7, the number may be too big. So to make it easier, I multiply first equation by 4. It'll be a little easier. If I multiply second equation by 7, 7 times 26 is a very, very big number. So multiply first equation by 4, that's a little easier. If I multiply first equation by 4, I have ax here. But they have the same sign. They have different sign. So multiply by negative 4. If I multiply first equation by negative 4, negative 4 times 2 is negative a. Negative ax will cancel positive ax. So multiply first equation by negative 4. I have negative ax. Negative 4 times 7 is negative 28y. Negative 4 times negative a is positive 32. Leave the second equation the same. I have ax minus y equal to 26. Then combine like terms. When I combine like term, positive ax and negative ax get cancelled. Negative 28y and negative y. If there's no coefficient, consider there's a number 1 in the front. If there's no coefficient, consider there's number 1 in the front. When we're adding two numbers with the same sign, keep the sign and the magnitude. 28 plus 1 is 29. When we're adding two numbers with the same sign, keep the sign and the magnitude. 28 plus 1 is 29. Like term is y, which stays the same. Then on the right side, add the numbers. 32 plus 26 is 58. 32 plus 26 is 58. In order to get y by itself, divide both sides by negative 29. On the left side, negative 29 on the top and the bottom get cancelled. We get y by itself. On the right side, positive number divided by negative number, answer is always negative. When we divide two numbers with different sign, answer is negative. 58 divided by 29 is 2. So here we know y is negative 2. Once I know y, we can substitute y into one of the equations, solve for x. Let me substitute y into the second equation. I have ax minus negative 2 equal to 26. I substitute negative 2 for y. Then double negative is positive. We have ax plus positive 2 equal to 26. In order to get x by itself, I need to eliminate 2 first, then eliminate number a. So I can subtract 2 from both sides. On the left side, positive 2, negative 2 get cancelled, get ax by itself. On the right side, 26 minus 2 is 24. In order to get x by itself, I can divide both sides by a. On the left side, positive a on the top and the bottom get cancelled. We get x by itself. On the right side, 24 divided by a is 3. So And the final answer, x comma y equal to 3 comma negative 2. Or we can write the answer as s equal to 3, y equal to negative 2. That's the answer. Number 11. 3x plus 4y equal to 23. 2x minus 7y equal to negative 4. We try to solve the equation using elimination method. That means we try to eliminate one of the variable first. Here, it looks like no matter what I multiply, I can never make 2 to be 3. And no matter what I multiply, I can never make 4 to be 7. That means, in this case, I need to multiply both equations by some number. In this case, we need to multiply both equations by some number. Look at the coefficient here. We have 3 and 2, 4 and 7. It looks like the first pair is a little smaller than second pair. 2 and 3 is a little less than 4 and 7. So choose the smaller pair. For 2 and 3, least common multiple is 6. For number 2 and 3, 3 and 2, the least common multiple is 6. In order to make 3 to be 6, I need to multiply 3 by 2. In order to make 2 to be 6, I need to multiply 2 by 3. If I multiply first equation by 2, I have 6x here. If I multiply second equation by 3, I also have 6x. But we want these two terms have opposite sign. So I multiply one of them by negative number. Now if I multiply first equation by negative 2, I have negative 6x. If I multiply second equation by 3, I have 6x. Negative 6x and positive 6x will be cancelled. Here I multiply first equation by negative 2. I have negative 6x minus ay equal to negative 46. I multiply each term by negative 2. Here I multiply each term by negative 2. 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. 23 times negative 2 is negative 46. Then next, I multiply second equation by 3. 2x times 3 is 6x. Negative 7y times 3 is negative 21y. Negative 4 times 3 is negative 12. Then when I add the equation, negative 6x and positive 6x get cancelled. Negative ay and negative 21y, I can try to combine like terms. When we add in two numbers with the same sign, keep the sign and the magnitude. 21 plus 8 is 29. Leave like term the same. Then on the other side, negative 46 and negative 12. When we add in two numbers with the same sign, keep the sign and the magnitude. 46 plus 12 is 58. Then in order to get y by itself, I divide both sides by negative 29. Divide both sides by negative 29. On the left side, negative 29 on the top and the bottom get cancelled. We get y by itself. On the right side, negative 58 divided by negative 29. When we divide two numbers with the same sign, answer is positive. 58 divided by 29 is 2. So y is positive 2. Once we know y, substitute y into one of the equations, solve for x. Let me substitute y into the first equation. It will be 3x plus 4 times 2 equal to 23. I substitute y into the first equation, then solve for x. Substitute y into the first equation, solve for x. 4 times 2 is 8. In order to get x by itself, I first of all subtract a from both sides. On the left side, positive a and negative a get cancelled, we get 3x by itself. On the right side, 23 minus a is 15. In order to get s by itself, I divide both sides by 3. On the left side, number 3 on the top and the bottom get cancelled, we get s by itself. On the right side, 15 divided by 3 is 5. So the final answer, x comma y equal to 5 comma 2. That's the answer. Or we can say x equal to 5, y equal to 2. That's another way to write an answer. Number 12. 5x minus 3y equal to a, and 7y minus 4y equal to 11. First of all, let's observe the equation. For number 5, no matter how I multiply, I can never get 7. And for number 3, no matter how I multiply, I can never get 4. So in this case, we need to multiply both equations by some number to match the coefficient. So observe, here is 7x. Observe the coefficient. For first pair, 5 and 7, second pair, 3 and 4. It looks like 3 and 4 is smaller than 5 and 7. So let's use smaller pair, find the least common multiple. For 3 and 4, the least common multiple is 12. If I multiply 3 by 4, I can make 12. If I multiply 4 by 3, I can also make 12. Now observe. Negative 3y times 4 would be negative 12y. Negative 4y times 3 would be negative 12y. They have same sign, but we want two terms have the same value but different sign. So in order to make different sign, I multiply first equation by negative 4. If I multiply first equation by negative 4, it will be positive 12y, and the bottom is negative 12y. If I multiply 3, bottom is negative 12y. Top is positive 12y. Positive 12y and negative 12y. When I add the equation, they get cancelled. So I multiply first equation by negative 4. Negative 4 times 5x is negative 20x. Negative 4 times negative 3y is positive 12y. Negative 4 times a is negative 32. On the bottom, multiply the equation by 3. 3 times 7x is 21x. 3 times negative 4y is negative 12y. 3 times 11 is 33. If I add the equation, I try to combine like terms. Negative 20x plus 21x. When adding two numbers with different sign, keep the sign from the number that has larger magnitude. 21 has larger magnitude, so I keep positive sign. Then subtract the magnitude. 21 minus 20 is 1. Like term is x, leave it the same. So I get positive 1x. Then positive 12y and negative 12y, when I combine like term, they get cancelled. On the right side, negative 32 plus 33. When we're adding two numbers with different sign, keep the sign from number that has larger magnitude. Here 33 has larger magnitude, so I keep positive sign. Then subtract the magnitude. 33 minus 32 is 1. Then we have 1x equal to 1. We know 1x is the same as x. Positive 1 is 1. 1x is the same as x. Positive 1 is 1. So we know x equal to 1. Once we know x, we can substitute x and solve for y. Let me substitute x into the first equation. I have 5 times 1 minus 3y equal to a. I substitute 1 for x, then solve the equation for y. 5 times 1 is 5. In order to get y by itself, I need to eliminate 5 first, then eliminate negative 3. So I can subtract 5 from both sides. On the left side, positive y and negative y cancel. We get negative 3y by itself. On the right side, a minus 5 is 3. In order to get y by itself, I can divide both sides by negative 3. Negative 3 on the top and the bottom get cancelled. We get y by itself. On the right side, positive 3 divided by negative 3. When we divide two numbers with opposite sign, answer is negative. 3 divided by 3 is 1. So the final answer as y is 1 comma negative 1. Or we can write the answer as s equal to 1, y equal to negative 1. So that's what we learned last class. Today I'll show you exponents. X raised to power n. This letter x is called the base. This letter x is called the base. This letter n is called the exponent. X raised to power n. This x is called the base of this expression. And this n is called the exponent. X to the power n, it means x to the power n, it means x times x times x n times. X to the power n means x times x times x n times. That means they are nx multiplied together. Let me show you some simple examples here. Say 2 to the power 4. 2 to the power 4, it means there are 4 2's multiplied together. 2 to the power 4 means there are 4 2's multiplied together. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 2 times 2 is 4. The other 2 times 2 is 4. 4 times 4 is 16. 5 to the power 3. That means there are 3 5 multiplied together. 5 to the power 3. That means there are 3 5 multiplied together. 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. 25 times 5 is 125. Negative 7 raised to power 2. Negative 7 raised to power 2. That means negative 7 times negative 7 twice. 2 negative 7 multiplied together. Negative 7 times negative 7. Double negative is positive. 7 times 7 is 49. For the final answer, if it's positive, we don't write positive sign. So the answer is positive 49. We simply write 49. We don't write positive sign. If an answer is positive, we don't write positive sign. Negative 3 to the power 4. That means negative 3 multiplied by itself 4 times. Negative 3 times negative 3 times negative 3 times negative 3. Negative 3 to the power 4 means there are 4 negative 3's multiplied together. Negative 3 times negative 3 is positive 9. Negative 3 times negative 3 is positive 9. 9 times 9 is 81. Those are simple examples about exponents. Today we will study rule of exponents. Today we'll study rule of exponents. The first rule, x raised to power 1 is the same as x. every number raised to power 1 is the same as the number itself. X raised to number 1, that means only 1x multiplied together. X raised to power 1 means only 1x multiplied together. X to the power n means there are nx multiplied together. X to the power 1 means there's only 1x multiplied together. So x to the power 1 is the same as x. Next, x to the power 0 is 1. Why is that true? Why x to the power 0 is 1? Let's look at some example. What's 2 to the power 1? 2 to the power 1 is 2. How about 2 to the power 2? 2 raised to power 2. 2 times 2 is 4. How about 2 raised to power 3? 2 raised to power 3. 2 times 2 times 2 is 8. How about 2 to the power 4? 2 to the power 4 means 2 times 2 times 2. Now 4 2's multiply together, which is 16. 2 to the power 5. Now 5 2's multiply together. If you multiply correctly, it should be 32, and so on. Now, how about 2 to the power 0? How do we find out what's 2 to the power 0? Observe the sequence here. From 2 to 4, 4 to 8, 8 to 16, 16 to 32. It looks like from 2 to 4, if I multiply 2 by 2, I can make 4 here. If I multiply 4 by 2, I can make 8 here. If I multiply 8 by 2, I can make 16 here. If I multiply 16 by 2, I can make 32. So, for the sequence going to the right, I multiply each number by 2. That means for the sequence going backward, I do the opposite operation. I divide each number by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if I keep going, from right to left, I keep dividing each number by 2. So 2 divided by 2 will be 1. So you can see that 2 to the power 0 is 1. The same argument works for 3 to the power 0, 4 to the power 0, 5 to the power 0. So in general, x raised to power 0 is 1. X raised to power 0 is 1. Rule number 3. X to the power n times x to the power m. What do we get? X to the power n times x to the power m. What do we get? Again, let's look at some examples. X to the power n, x to the power m. Think of this. X to the power, say, 4 times x to the power 5. What do we get? X to the power 4 times x to the power 5. X to the power 4 means there are 4x multiplied together. X to the power 5 means there are 5x multiplied together. 4x multiplied together times 5x multiplied together. Together we can count that they are totally 9x together, right? They are totally 9x they are totally 9x. So together is x to the power 9. If they are 9x multiplied together, the answer is x to the power of 9. Another example, y to the power 3 times y to the power 4. Another example, y to the power 3 means there are 3 y's multiplied together, y times y times y times y to the power 4 means there are 4 y's multiplied together, y times y times y times y. So 3y together, 4y together. If we count, there are totally 7 y's. We have 7 y's multiplied together. So 7 y's means y to the power 7. So observe the relationship here. If we observe the exponent, we can see that 4 plus 5 is 9. 3 plus 4 is 7. So it looks like when we multiply two numbers with the same base, we add the exponent. 4 plus 5 is 9. When we multiply two numbers with the same base, we add the exponent. 3 plus 4 is 7. So for rule number 3, if we multiply two numbers with the same base, we add the exponent. That's x to the power of n plus m. When we multiply two numbers with the same base, we add the exponent. Rule number 4. X to the power n divided by x to the power m. What do we get? X to the power n divided by x to the power m. What do we get? Let's look at some examples. Say a to the power 6 divided by a to the power 2. What do we get? A to the power 6 divided by a to the power 2. A to the power 6 means there are 6 a's multiplied together. 1, 2, 3, 4, 5, 6. A to the power 6 means there are 6 a's multiplied together. On the bottom, a to the power 2 means there are 2 a's multiplied together. Then we try to cancel a. When we divide, we try to cancel a. We cancel a one by one. I can cancel 1a from the top, 1a from the bottom. Then I can cancel another a from the top, another a from the bottom. What's left is 4 a's. 1, 2, 3, 4. I cancel 1a from top, 1a from bottom, 1a from top and bottom, 1a from top and bottom. I have 4 a's left on the top. A times A times A, there are 4 a's together. 4 a's together means a to the power of 4. 4 a's multiplied together, that means a raised to the power of 4. How about b to the power 7 divided by b to the power 4? B to the power 7 divided by b to the power 4. B to the power 7 means there are 7 b's on the top. 1, 2, 3, 4, 5, 6, 7. B to the power 7 means there are 7 b's on the top. B to the power 4 means there are 4 b's on the bottom. 1, 2, 3, 4. B to the power 4 means there are 4 b's on the bottom. We can cancel 1b from the top, 1b from the bottom. Keep cancelling. I can cancel 1b from the top, 1b from the bottom. Keep cancelling. I can cancel 1b from the top, 1b from the bottom. Then again, 1b from the top, 1b from the bottom. So the b's on the bottom get completely cancelled. We have 3b on the top left. B times b times b. b times b times b, that's b to the power 3. When we have 3 b's multiplied together, the answer is b raised to the power of 3. Now, let's observe the relationship here. It looks like 6 minus 2 is 4. 7 minus 4 is 3. 6 minus 2 is 4. 7 minus 4 is 3. So it looks like when we divide two numbers with the same base, we subtract the exponent. When we divide two numbers with the same base, keep the base, subtract the exponent. 6 minus 2 is 4. When we divide two numbers with the same base, we keep the base, subtract the exponent. Keep the base, subtract the exponent. So, for division, when we divide two numbers with the same base, we keep the base, then subtract the exponent. That's rule number 4. Rule number 5. X to the power n raised to power m. X to the power n raised to power m. What do we get? X to the power n raised to power m. Let's look at some simple examples. C raised to power 3, then raised to power 4. C raised to power 3, then raised to the power 4. C raised to power 3 raised to power 4 means C to the power 3 multiplied by itself 4 times. That's what power 4 means. Power 4 means I repeat the same thing 4 times. C to the power 3 times C to the power 3 times C to the power 3 times C to the power 3 4 times. That's what power 4 means. Then for each parenthesis, C to the power 3 is C times C times C. For each parenthesis, C to the power 3 is C times C times C. In each parenthesis, C to the power 3 is C times C times C. C times C times C. Let's count how many C do we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like there are 12 C's. If there are 12 C's, the answer should be C raised to power 12. If there are 12 C's, answer is C raised to power 12. Another example. How about D to the power 2 raised to power 5? D to the power 2 raised to power 5. Something raised to power 5. Anything raised to power 5 means I repeat the same thing 5 times. So I get D squared times D squared times D squared times D squared times D squared, totally 5 times. D squared, D squared, D squared, D squared, D squared 5 times. D squared can be rewritten as D times D. D squared can be rewritten as D times D. D squared is D times D. D squared is D times D. D squared is D times D. Let's count. How many D do we totally have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a total of 10 D's. We have a total of 10 D's. If there are 10 D's multiplied together, we have D raised to power of 10. If there are 10 D's multiplied together, we have D raised to power of 10. So, observe the relationship here. It looks like 3 times 4 is 12. 2 times 5 is 10. So, if there's exponent inside the parentheses and outside the parentheses, we multiply the exponents. keep the same base. If there's exponent inside the parentheses and outside the parentheses, we multiply the exponents and keep the base. So if there's exponent inside and outside the parentheses, we keep the base, multiply the exponent. We have x raised to the power of n times m. That's rule number 5. Rule number 6. X times y raised to power n. What do we get? X times y raised to power n. What do we get? Let's look at some example about x times y raised to power n. Let's look at some example about x times y raised to power n. For example, if we have p times q raised to power 4, what does it mean? P times q raised to power 4, it means p times q 4 times, that's what power 4 means. P times q raised to power 4 means p times 4 multiplied by itself 4 times. So we have p times q, p times q, p times q, p times q. We have p times q, p times q. The same thing multiplied by itself 4 times. That's what power 4 means. Then this can be rewritten as, if I drop on the parentheses, group all p together, this can be rewritten as p times q, 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 q. I can drop on the parentheses, put all the p's together, 1, 2, 3, 4. Put the first 4 p together, then put 4 q's together. Put the 4 q's together. We have p times p times c times c. We have 4 p's multiplied together, which is p to the power 4. And we have 4 q's multiplied together, that's q raised to power 4. So the final answer is p raised to power 4, q raised to power 4. Another example, if I take st raised to power 5, for example, s times t raised to power 5, it can be rewritten as s times t multiplied by itself 5 times. S times t, s times t, s times t, another s times t. Together, we have 5 st's multiplied together. Now, I can switch order, group all s together, then group all t together. If I group s together, I have s times s times s times s times s. If I group all t together, I have t, 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 t. So if there are 5s multiplied together, I get s to the power 5. If there are 5 t's multiplied together, I get t to the power 5. So the final answer is s to the power 5, t to the power of 5. Now let's look at the relationship here. P times q to the power 4, I get p to the power 4, q to the power 4. For s times t to the power 5, I get s to the power 5, t to the power 5. That means if there's parentheses, if there's exponent outside the parentheses, I can distribute exponent into the parentheses. I can distribute power 4 to each p and q. If there's exponent outside the parentheses, I can distribute the exponent to both of them. I get s to the power 5, t to the power 5. So if there's exponent outside the parentheses, I can distribute exponent to each letter inside the parentheses. So for number 6, if there's a power n outside the parentheses, I can distribute power n to each of them in the parentheses. I get x to the power n times y to the power n. It's rule number 6. Rule number 7. How about x over y to the power n? How about x over y to the power n? Let's look at some examples. For example, if we have u over v raised to power 5, u over v raised to power 5, it can be rewritten as u over v multiplied by u over v multiplied by u over v 5 times. U over v to the power 5 is u over v times u over v times u over v, u over v, u over v 5 times. That means we multiply numerator to the numerator and denominator to the denominator. I have u times u times u times u. When we multiply fraction, we multiply numerator to the numerator and denominator to the denominator. We have 5 u's multiplied together. That's u to the power 5. And we have 5 v's on the bottom. That's v to the power 5. Let's look at another example. Say p over q to the power 3. P over q to the power 3. That means p over q times p over q times p over q 3 times. If we multiply the top to the top, bottom to the bottom. That means p times p times p over q times q times q. P times p times p, that's p to the power of 3. 3p multiplied together, that's p to the power of 3. On the bottom, 3q multiplied together, that's q to the power of 3. So observe the relationship here. U over v to the power 5, I get u to the power 5, v to the power 5. P over q raised to the power 3, I get p to the power 3, q to the power 3. So it looks like if there's exponent outside the parentheses, I distribute exponent to each of them inside the parentheses. I distribute power 5 to u, distribute power 5 to v. I get u to the power 5 over v to the power 5. And for the other example, I distribute 3 to both of them. I get p to the power 3 and q to the power 3. So when there's exponent outside the parentheses, we distribute exponent to each of them. So when there's exponent outside the parentheses, we distribute exponent to each of them. I get x to the power n over y to the power of n. That's rule number 7. Rule number 8. X raised to negative n. If the power is exponent, what should we do? If the power is exponent, what should we do? Let's look at some example. For example, letter A to the power negative 6. I don't know what it is, but we know that if A to the power of negative 6 times A to the power of positive 6, what should we do? When we multiply two numbers with the same base, we add an exponent. We have negative 6 plus 6. Negative 6 plus 6 is 0. A to the power 0. By rule number 2, every number raised to power 0 must be 1. Every number raised to power 0 must be 1. So a raised to power 0 must be 1. So we know that a raised to negative 6 times a to the positive 6 equal to 1. If I try to isolate a to the negative 6, I divide both sides by a to the positive 6. If I try to isolate this, I divide both sides by a to the positive 6. So on the left side, a raised to positive 6 can cancel. We get a raised to negative 6. So that equal to 1 over a to the power 6. So a raised to power of negative 6 is 1 over a to the power of 6. Similarly, x raised to power of negative n can be rewritten as 1 over x to the power n. So rule number 8 says, if an exponent is negative, put 1 on top, make it positive. If I combine rule number 5, number 6, number 7 together, if I combine rule number 5, number 6, number 7 together, what do we get? Rule number 5, number 6, number 7. If I combine rule number 5, number 6, number 7 together, I have x raised to power a, y raised to power b raised to power n. When there's exponent outside the parentheses, I can distribute exponent into the parentheses and multiply the exponents. If there's exponent outside the parentheses, I can distribute exponent into the parentheses, then multiply the exponents. And same rule works for division. If there's exponent outside the parentheses, I can distribute exponent into the parentheses and then multiply the exponent. X raised to an over y raised to bn. Then same thing. If we have x raised to power a, y raised to power b over z raised to power c raised to power n, we distribute power n to each exponent. We have a raised to x raised to an y raised to bn over z raised to cn. We distribute the power to each of them. And for rule number 4, there is an extension for rule number 4. Rule number 4 says when we divide exponent, we subtract exponent. For rule number 4, there's an extension. Of rule number 4. When we have x to the power n over x to the power m, if the power on the top is larger than the bottom, we can subtract the exponent. We can see that. If the power on the top is larger, we see that we subtract the exponent. But what if the power on the top and the bottom is smaller? If n is greater than m, we subtract the exponent. We have x to the power n over x to the power m equal to x to the n minus m. If the degree of the top is larger, we use top minus bottom. Keep the base the same. Use the top power minus the bottom power. What if the power is the same? or if the power is the same. If the power is the same, subtract the power. M minus M, if they are the same, you subtract the power, you get 0. If the power is the same, you get power 0. If the power is the same, M minus M is 0. X raised to power 0 is 1. What if the power on the top is smaller than the bottom? What if the power on the bottom is larger? Then what should we do? What if the power on the bottom is larger? Then what should we do? Look at an example. E to the power of 3 over E to the power of A. What should we do? E to the power of 3 means there are 3 e's on the top. E to the power of A means there are 8 e's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. We cancel e's one by one. Cancel 1 e from top, 1 e from bottom, 1 e from top, 1 e from bottom, 1 e from top, 1 e from bottom. And there's nothing left on the top, but we have 5 e left on the bottom. If there's nothing left on the top, we write 1 on the top. And if there are 5 e's left on the bottom, we write e to the power of 5. Another example, f to the power 4 over f to the power 6. On the top, f to the power 4 means there are 4 f's multiplied together. F to the power 6 means there are 6 f's multiplied together. Then we cancel the f's one by one. Cancel 1 f from the top, 1 f from the bottom, 1 f from top, 1 from bottom, 1 from top, 1 from bottom, 1 from top, 1 from bottom. If I cancel 1 from top, 1 from bottom, what's left is 2f on the bottom. So we have 1 over f squared. If you observe the rule, you can see that if the power on the bottom is larger, we take the bottom power minus the top. Take the bottom minus the top. A minus 3 is 5. If there's nothing left on the top, write 1 on the top. So if the bottom has larger degree, take bottom minus top. Then write 1, keep 1 on the top. If the bottom is larger, has larger degree, has larger power, keep f on the bottom. Use larger minus the top. Larger minus smaller, we get put 1 on the top. So if the bottom exponent is larger, we put 1 on top. Then use the bottom minus the top. So that's extension of rule number 4. If the top degree is larger, you use top degree minus bottom degree. If the degree is the same, if the power is the same, answer becomes s to the power 0, which is 1. If the bottom degree is larger, write 1 on top. Keep s on the bottom. Then use the bottom degree minus the top degree. Bottom power minus the top power. That's the extension of rule number 4. Extension of rule number 8. Extension of rule number 8. Rule number 8 deals with negative exponent. When exponent is negative, put 1 on top, make it positive. So extension of rule number 8. If we have x raised to negative power on the bottom and we move it to the top, If we have exponent on the negative exponent on the bottom, we move it to the top, we make it positive. If we have exponent on the bottom, I want to make it positive, I move it to the top. I make it positive and move to the top. If exponent is negative on the bottom, I want to make it positive, I move it to the top, make it positive. If exponent is negative on the top, I want to make it positive, I move it to the bottom, make it positive. If exponent is negative on the bottom, and if I want to make it positive, I move it to the top, make it positive. If exponent is negative on the top, I want to make it positive, I move it to the bottom, make it positive. Next, let's look at some examples. Simplify each of the following expressions. First one, x raised to power 2 times x raised to power 5. When we multiply two numbers with the same base, we keep the base and the exponent. 2 plus 5 is 7, and that's the answer. Next, m to the power 3 times m to the power 7 times m to the power 2. Same thing, by rule number 3, when we multiply numbers with the same base, we keep the base and the exponent. 3 plus 7 is 10. 10 plus 2 is 12. When we multiply numbers with the same base, keep the base and the exponent. 3 plus 7 plus 2 is 12. Next, 5x times 3x to the power 4. First of all, if there's a number in the front, we multiply the number in the front first. If there's a number in the front, multiply the number in the front first. I get 15. 5 times 3 is 15. Then next, multiply x together. X times x to the power 4. If there's no power, if there's no exponent, by rule number 1, if there's no exponent, we assume exponent is 1. Then by rule number 3, when we multiply two numbers with the same base, keep the base, add the exponent. 1 plus 4 is 5. And that's the answer. Number 4. y raised to negative 4 times y. So first of all, if there's no exponent, we assume exponent is 1. That's rule number 1. If there's no exponent, we assume exponent is 1. Next, by rule number 3, when we multiply two numbers with the same base, we keep the base and exponent. Keep the base and exponent. Negative 4 plus 1. What's negative 4 plus 1? When we're adding two numbers with different sign, keep the sign from the number that has larger magnitude. Here, negative 4 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 4 minus 1 is 3. So we get y raised to negative 3. Now, be very, very careful. We are not done. We are not done. Note. For the answers in a simple list form, all exponents must be positive. be very careful. For the answers in the simplest form, all exponent must be positive. So for number 4, if we have negative exponent here, we are not done. One more step. By rule number A, if the exponent is negative, put 1 on the top, make it positive. By rule number A, if the exponent is negative, put 1 on the top, make it positive. So that's the final answer for number 4. Next. X to the power 6 over x to the power 2. By rule number 4, when we divide, if the power on the top, number 6 is called degree or power or exponent. This number 6 is called degree, exponent or power. It's called degree, exponent or power. They all mean the same thing. Number 6 is called power, degree or exponent. So when we divide, we take the top degree minus the bottom degree. If the top degree is larger, keep the base, take the top degree minus the bottom degree, I get x to the power 4. Number 6, x to the power 7 over x to the power of 3. Same thing. By rule number 4, when we divide, if the top degree is larger, take the top minus the bottom. 7 minus 3 is 4. Next. Y to the power 2 over y to the power 9. Y to the power 2 over y to the power 9. Now here, the bottom degree is larger. So by extension of rule number 4, if the bottom degree is larger, use the bottom, keep y on the bottom. Use the bottom minus the top. If the bottom has larger degree, keep y on the bottom, take bottom minus the top. 9 minus 2 is 7. Then if there's nothing left on the top, write 1 on the top. That's the extension of rule number 4. When the bottom degree is larger, you keep y on the bottom, use bottom degree minus the top degree, then put 1 on the top. Next. 16x to the power 3 over 6x to the power 4. 16x to the power 3 over 6x to the power 4. When we divide, and if there's a number in the front, simplify the numbers first. For 16 and 2, for 16 and 6, I can divide both numbers by 2 and make a over 3. Simplify the numbers first. For 16 over 6, I can divide both numbers by 2, make a over 3. Now observe x here. Bottom has larger degree here. X to the power 3, x to the power 4. Bottom has larger degree, so I keep x on the bottom. Then use bottom minus the top. 4 minus 3 is 1. 4 minus 3 is 1. So for the final answer, we write a over 3x. X to the power 1 is the same as x. Next. (2x over y raised to power 0). 2x over y raised to power 0. By rule number 2, everything raised to power 0 is 1. That's the answer. By rule number 2, everything raised to power 0 is 1. Next, 16x to the power 0. 16x to the power 0. So we know x to the power 0 is 1. So we get 16 times 1. 16 times 1 is 16. So be very careful. If there's no parentheses, power 0 only apply to x, not 16. But if there is parentheses, then everything raised to power 0 is 1, answer will be 1. If there is parentheses, everything raised to power 0 will be 1. But if there's no parentheses, we only apply power 0 to x. X to the power 0 is 1, which is 16. So be very, very careful. If there is no parentheses, power 0 only apply to x. X to the power 0 is 1. Then 16 times 1 is 16. But if there is parentheses, we consider this is the base. Everything raised to power 0 is 1. Next, y to the power 3 over y raised to negative 2. Y to the power 3 over y raised to power of negative 2. Since for the final answer, we want all exponents to be positive. When exponent is negative on the bottom, by the extension of rule number A, I can move it to the top, make it positive. By the extension of rule numbers A, I can move negative exponent to the top, make it positive. If I move the bottom to the top, I cannot leave it blank, so I put 1 on the bottom. I move y raised to negative 2 from bottom to the top, so exponent become positive. I cannot leave the bottom blank, so I put 1 there. Then on the top, when we multiply two numbers with the same base and exponent, I get y to the power 5 over 1. And every number over 1, I can drop 1. For any number, if it's divided by 1, I can drop on the bottom. I get y raised to power 5. That's the final answer. Next. For 4x over x raised to negative 5. 4x over x raised to negative 5. So same thing. We want all exponents to be positive. So if exponent is negative on the bottom, we can move it to the top, make it positive. So it can be rewrite as 4x times x to the power 5 over 1. Then multiply. When we multiply n exponents, if there's no exponent, we assume exponent is 1. So power 1 plus power 5, that's power 6. If the denominator is 1, I can drop the denominator. The answer is 4x raised to power of 6. Next. Two x to the power 3 y squared times 4xy raised to power 4. So if there's a number in the front, we multiply the numbers first. 2 times 4 is a. Next, we multiply x to x, multiply y to y. X to the power 3 times x. If there's no power, we assume the power is 1. So when we multiply, add the exponent. 3 plus 1 is 4. And for the y's, y to the power 2 times y to the power 4. When we multiply, we keep the base and the exponent. 2 plus 4 is 6. And that's the answer. Next. Three x squared y squared times 2x y to the power of 3 So same thing, we multiply the numbers in the front first. 3 times 2 is 6. Then we multiply x to x, multiply y to y. X squared times x, if there's no power, we assume the power is 1. So n power 2 plus 1 is 3. For the y, it's doing the same thing. When we multiply, keep the base. N power 2 plus 3 is 5. So the final answer is 6s to the power 3, y to the power of 5. Next, 6x squared y to the power 3 over ax to the power 4 y to the power 2. So if there's a number in the front, simplify the number first. 6 and 8, I can divide both numbers by 2. I can make it 3 over 4. Now observe x here. Since the bottom has larger exponent, I keep x on the bottom, then subtract exponent using the bottom minus the top. 4 minus 2 is 2. For y, since the top has larger exponent, I keep y on the top. Then use top exponent minus bottom exponent, I get power 1. For x, since the bottom exponent is larger, I keep x on the bottom, then subtract exponent, larger minus smaller. For y, since the top has larger exponent, I keep y on the top, then subtract exponent. 3 minus 2 is 1. For the final answer, we write 3y over 4x squared. If the power is 1, we don't write power 1. Next, 14x cubed y to the power 7 over 21 x to the power 5 y to the power of 2. 14x cubed y to the power 7 over 21 x to the power 5 y to the power 2. So if there's a number in the front, simplify the numbers first. For 14 and 21, we can divide both numbers by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Simplify the numbers first. Now look at x. For x, with power 3 on the top, power 5 on the bottom. Since the bottom has larger degree, larger power, bottom has larger power, I keep x on the bottom. The bottom has larger power, I keep x on the bottom, then subtract exponent. 5 minus 3, take bottom minus top. 5 minus 3 is 2. And for letter y, since the top has larger power, I keep y on the top, and take top minus bottom. 7 minus 2 is 5. And that's the final answer. Next, a to the power 2, b to the power 7 over a to the power 5, b to the power 3. A to the power 2, b to the power 7 over a to the power 5, b to the power of 3. Observe letter A first. Since the bottom has larger power, I keep a on the bottom, then subtract exponent. 5 minus 2, take larger minus smaller. 5 minus 2 is 3. Look at the b's. B to the power 7 over b to the power 3. Since the top has larger power, keep b on the top. Since the top has larger power, keep b on the top. And use larger power minus smaller power. 7 minus 3 is 4. And that's the final answer. Next, a raised to -1, b raised to power 2, a raised to -3, b raised to +7. So first of all, we want all exponents to be positive. First of all, we want all exponents to be positive. If exponent is negative on the top, we move it to the bottom, make it positive. If exponent is negative on the bottom, we move it to the top, make it positive. First of all, we want all exponents to be positive. If exponent is negative on the top, you bring to the bottom, make it positive. If exponent is negative on the bottom, bring to the top, make it positive. The b's stays the same. For letter A, if exponent is negative on the top, bring to the bottom, make it positive. If exponent is negative on the bottom, you bring to the top, make it positive. And the b has positive exponent. B has positive exponent, we leave it the same. Next, we simplify. On the top, let's observe A and B first. Letter A has larger power on the top. Letter A has larger power on the top. So I keep A on the top. Then subtract the power. Larger minus smaller. 3 minus 1 is 2. For letter B, the bottom has larger power. So I keep B on the bottom. Subtract the power is larger minus smaller. 7 minus 2 is 5. Next. (6x raised to -2), y raised to +4, 12x raised to power 3, y raised to -1, 6x raised to -2, y raised to power 4 over 12x raised to power 3, y raised to -1. So first of all, we can simplify the numbers first. For 6 and 12, if I simplify a number, I can divide both numbers by 6. For 6 and 12, I can divide both numbers by 6. I have 1 over 2. Then the rest stays the same for now. Simplify numbers first. Next, when the exponent is negative on the top, I can bring to the bottom, make it positive. When the exponent is negative on the bottom, we can bring to the top, make it positive. When the exponent is negative on the top, we can bring to the bottom, make it positive. When the exponent is negative on the bottom, we can bring to the top, make it positive. So 1 stays the same. I bring x to the -2 to the bottom. I bring it here, make +2. X to the power 3 stay on the bottom. Y to the power 4 stay on the top. Y raised to -1. If I bring it to the top, I make it +1. So 1 and 2 stays the same. X raised to -2, I bring to the bottom, make it +2. X to the power 3 stays the same. Y to the power 4 stays the same on the top. Y to the -1, when I bring to the top, I make it positive. Then on the top, y to the power 4 times y to the power 1. When we multiply two numbers with the same base, keeping the base and exponent, I get y to the power 5. One times every number is the number itself. 1 times y to the power 5 is y to the power 5. So I can drop 1. On the bottom, number 2 stays the same. X to the power 3 times x to the power 2 times x to the power 3. When we multiply two numbers with the same base, keep the base, multiply the exponent, so n exponent, 2 plus 3 is 5. When we multiply two numbers with the same base, keep the base, n exponent, 2 plus 3 is 5. So that's the final answer. Next. 2 raised to -3, x raised to -4, y raised to -5. 2 raised to -3, x raised to negative 4, y raised to negative 5. So when the exponent is negative on the top, we can bring to the bottom, make it positive. When the exponent is negative on the bottom, we can bring to the top, make it positive. So I bring 2 to the negative 3 to the bottom, I make it 2 raised to positive 3. I bring x to the negative 4 to the bottom, I make it x raised to positive 4. Then for y raised to negative 5, I bring to the top, make it y raised to positive 5. Then on the bottom, 2 to the power 3, that means 2 times 2 times 2 is a. We have ax to the power 4, y to the power 5. Then on the top and the bottom, since they have different bases, they cannot be simplified. We have power y on the top, power x on the bottom, they have different bases, they cannot be simplified. So that's the final answer. Next, x squared y raised to power 4. X squared y raised to power 4. If I combine rule number 5, number 6, number 7 together, by rule number 5, 6, 7, I can distribute power 4 into the parentheses. I can distribute the parentheses out. I can distribute the exponent outside the parentheses into the parentheses. By rule number 5, 6, and 7, I can distribute exponent outside the parentheses into the parentheses. 4 times 2 is 8. For letter y, if there's no power, we keep the power as 4. When I distribute power 4, I write it as y raised to power 4. And that's the final answer. They have different bases, they cannot be combined. Next, x raised to power 3, y raised to power 2, raised to power 5. Same thing. If there's exponent outside the parentheses, distribute the outer exponent into the parentheses. So take 5 times 3 and 5 times 2. 5 times 3 is 15. 5 times 2 is 10. Now, since they have different bases, they cannot be combined. So that's the final answer. We leave it the way it is. Next. Negative 5x squared. Negative 5x squared. When there is exponent, we distribute. When there's exponent outside the parentheses, we distribute the exponent to each of them in the parentheses. So we get negative 5 raised to power 2 times x raised to power 2. Negative 5 raised to power 2, that means negative 5 times negative 5, which is 25. X squared, that cannot be simplified, so I leave it the way it is. Next. Negative x, y raised to negative 1, raised to negative 2. Negative x, y raised to negative 1, raised to negative 2. So, if there's exponent outside the parentheses, distribute the exponent first. If there's exponent outside the parentheses, distribute the exponent first. We have negative x raised to negative 2. Negative x raised to negative 2. For letter y, negative 2 times negative 1. When we multiply two numbers of the same sign, answer is positive. 2 times 1 is 2. Then, when exponent, for the final answer, exponent must be positive. For the final answer, exponent must be positive. When the exponent is negative, bring to the bottom, make it positive. If there's no bottom, assume the bottom is 1. So bring negative x raised to negative 2 to the bottom, make exponent positive. If there's no bottom, put 1 on the bottom. Then bring negative x raised to negative 2 to the bottom. If I bring negative x raised to negative 2 to the bottom, I make exponent positive. Y squared stays on the top. On the bottom, negative x squared means negative x times negative x. double negative is positive. X times x is s squared. So the final answer is y squared over s squared. That's the final answer, and it cannot be simplified. They have different bases. They cannot be simplified. So that's the final answer. Number 25. Negative x raised to negative 3 times y raised to negative 2. So when there's exponent outside the parentheses, distribute the exponent first. We have negative x raised to positive 6. Negative 2 times negative 3. When we multiply two numbers with the same sign, double negative becomes positive. And when we distribute negative 2 to letter y, if there's no exponent is negative 2. Keep negative sign in the front. When the exponent is negative, we try to bring it to the bottom. We have negative x raised to power 6 over y to the positive 2. When there's negative exponent, we try to make it positive. So I bring it to the bottom. If there's no denominator, assume the denominator is 1. I bring y raised to negative 2 to the bottom. I make it y raised to positive 2. When there's exponent on the top, bring it to the bottom, make it positive. For the final answer, all exponents must be positive. And then that's the final answer. The top has x, bottom has only y. They have different bases. They cannot be simplified. So that's your final answer. Next. 6x squared y raised to power 3 all raised to negative 1. 6x squared y to the power 3 all raised to power of negative 1. So distribute the power to each of them. Distribute the power to each of them. We have 6 raised to negative 1, x raised to negative 2, y raised to negative 3. For number 6, if there's no exponent, we distribute power 1 to number 6. We have 6 raised to negative 1. For x, if there is an exponent, we multiply the exponent. Negative 1 times 2 is negative 2. And for letter y, multiply the exponent. 1 times 3 is negative 3. For the final answer, if an exponent is negative, we try to bring to the bottom. Put 1 on the bottom. Try to bring each of them to the bottom. When the exponent is negative on the top, bring to the bottom, make it positive. So on the bottom we have 6 x squared y to the power 3. We bring everything, bring negative exponent to the bottom, make it positive. We get 6 to the power 1, x to the power 2, y to the power of 3. If there's nothing left on the top, put 1 on the top. This 1 is a placeholder. You cannot leave the top blank. The final answer is 1 over 6x squared y cubed. 6 to the power 1 is 6. That's the final answer. Next. X over y cubed square. X over y cubed square. If there's an exponent outside the parentheses, we distribute the exponent to each of them. We have x squared. For letter y, 2 times 3 is 6, and they cannot be simplified. That's the final answer. They cannot be simplified. That's the final answer. Number 28. X to the power 4, y raised to negative 3 over z squared. X to the power 4, y raised to negative 3 z squared. So when there's exponent outside the parentheses, we distribute exponent to each of them. We have x to the power of a, 2 times 4 is a, y to the power of negative 6, 2 times negative 3 is negative 6, z to the power of 4, 2 times 2 is 4. when exponent is negative on the top, we bring to the bottom, make it positive. So the final answer, x to the power 8, z to the power 4, y to the power 6. When exponent is negative on the top, bring to the bottom, make it positive. Usually for the final answer, on the bottom, we want to write y to the power 6 times z to the power 4. We want the letters in alphabetical order, so write y first, z after. For the final answer, we want to put it in alphabetical order, so write y first and z come after y. Next, 3x squared over 4y raised to negative 1 raised to negative 3. 3x squared over 4y raised to negative 1 raised to negative 3. So first step, we distribute the exponent to each of them, to each expression in the parentheses. We have 3 raised to negative 3 x raised to negative 6. Negative 3 times positive 2 is negative 6. On the bottom, 4 raised to negative 3, y raised to positive 3. Negative 3 times negative 1 is positive 3. Double negative become positive. If there's no exponent, we just simply add exponent to the number. 3 raised to negative 3, 4 raised to negative 3. Then simplify. When the exponent is negative on the top, we move to the bottom, make it positive. When the exponent is negative on the bottom, we move it to the top, make it positive. When the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. So on the top, I have 3x raised to negative 3, x raised to negative 6. If I bring to the bottom, I make it positive, make exponent positive. 3 to the negative 3, I move to the bottom, make it 3 raised to positive 3. X raised to negative 6, I move to the bottom, make it x raised to positive 6. Then on the bottom, 4 raised to negative 3, I move it to the top, make it positive 3, make it 4 raised to positive 3. Y raised to power 3, the power is positive, so I leave it on the bottom. Y raised to positive 3, since the power is positive, I leave it on the bottom. Then calculate the numbers. 4 raised to power 3 means 4 times 4 times 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64 on the top. On the bottom, 3 raised to power 3, that means 3 times 3 times 3. 3 times 3 times 3. 3 times 3 is 9. Times another 3 is 27. X to the power 6, y to the power 3, they cannot be simplified because they have different bases. They cannot be simplified. So that's the final answer. Next, 3x raised to negative 1 raised to negative 2 over 6y squared raised to negative 1. 3x raised to negative 1 raised to negative 2 over 6y squared raised to negative 1. So first step, we try to distribute the exponent first. Distribute the exponent first. We have 3 raised to negative 2, x raised to positive 2. Negative 2 times negative 1 is positive 2. On the bottom, we have 6 raised to negative 1, y raised to negative 2. Negative 1 times positive 2 is negative 2. Then, when the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, we move to the top, make it positive. When the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. So I have 3 to the power 2. When I bring 3 to raised to negative 2, when I bring to the bottom, negative 2 becomes positive 2. When I bring 6 raised to negative 1, y raised to negative 2 to the top, I have 6 raised to positive 1, y raised to positive 2, and x raised to positive 2 stays on the top. X raised to positive 2, since the power is positive, it stays on the top. Then simplify. On the top, we have 6x squared y squared. Write numbers first. For letters, put in alphabetical order, x squared, y squared. On the bottom, 3 squared is 9. On the bottom, 3 squared is 9. Then simplify 6 and 9. For 6 and 9, I can divide both numbers by 3. So I have 2 over 3. I divide both numbers by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Then we have x squared, y squared. Next, 2x cubed y squared raised to power 4 over 6x y squared squared. 2x cubed y squared raised to power 4 over 6x y squared squared. If there's exponent outside the parentheses, distribute the exponent first. I have 2 raised to power 4 times x raised to power 12. 4 times 3 is 12. Y raised to power of 8. 4 times 2 is 8. On the bottom, we have 6 squared x squared y raised to power 4. 2 times 2 is 4. Then we can calculate the number first. 2 raised to power 4 is 16. 2 times 2 times 2 times 2 is 16. 6 raised to power 2 is 36. X to the 12, y to the 8. X squared, y to the power of 4. Next, let's simplify the numbers first. For 16 and 36, I can divide both of them by 4. 16 divided by 4 is 4. 36 divided by 4 is 9. Now look at x. Since the top has larger power, we keep x on the top. Then subtract the exponent. 12 minus 2 is 10. Look at letter y. Since the top has larger exponent, I keep y on the top. And take larger exponent minus smaller exponent. I get 4. The final answer is 4x to the power 10, y to the power 4 over 9. Next, three x squared raised to negative 3 over 6x raised to negative 1 times y squared. 3x squared raised to negative 3 over 6x raised to negative 1 times y squared. So when there's exponent outside the parentheses, distribute the exponent first. We have 3 raised to negative 3, x raised to negative 6. Negative 3 distribute to 3. We have 3 raised to negative 3. When I distribute negative 3 to 2, to x squared, negative 3 times 2 is negative 6. Distribute power 2 to each of them. We have 6 to the power 2, x to the power of negative 2. 2 times negative 1 is negative 2. Y to the power of positive 2. Then, when the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. When the exponent is negative on the top, move to the bottom, make it positive. When the exponent is negative on the bottom, move to the top, make it positive. So 3x cubed, 3x raised 3 raised to negative 3. When I move to the bottom, it becomes 3 raised to positive 3. X raised to negative 6. When I move to the bottom, it becomes x raised to positive 6. Then on the bottom, 6 squared stays there. X raised to negative 2 go to the numerator. Exponent becomes positive. Y squared stays there. So on the bottom, 6 squared y squared stays there. X raised to negative 2, I move to the top. It becomes positive exponent. 3x raised to negative 3, move to the bottom. It becomes positive 3 raised to positive 3. X raised to negative 6, when I move to the bottom, it becomes x raised to positive 6. Then we can calculate the numbers first. We have x squared on the top. On the bottom, calculate the numbers first. 3 raised to power 3 is 27. X to the power 6. 6 squared is 36. Y to the power of 2. Then we can try to multiply the numbers first. 27 times 36. 6 times 7 is 42. Write down 2, carry 4 over. 6 times 2 is 12. 12 plus 4 is 16. 3 times 7 is 21. Write down 1, carry 2 over. 3 times 2 is 6. 6 plus 2 is 8. Then add the numbers. 6 plus 1 is 7. 1 plus 8 is 9. Multiply the numbers, I get 972. X to the power 6, y to the power 2. On the top we have x squared. Now try to cancel x. We have x on the top and the bottom. Observe x here. Since the bottom has larger exponent, we keep x on the bottom. Then subtract the exponent. 6 minus 2 is 4. Then 972 stay on the bottom. Y squared stay on the bottom. If there's nothing left on the top, write 1. We cannot leave the top blank. This 1 is placeholder. That's the final answer. Next. (3x raised to negative 1 over y raised to power 3 times 9x squared over y to the power 3 raised to negative 2. So when there's exponent outside the parentheses, distribute the exponent first. We have 3 raised to power 3 times x raised to negative 3 y raised to power 3. Distribute the exponent first. Same thing for the other one. Distribute the exponent first. We have 9 raised to negative 2, x raised to negative 4, y raised to negative 6. Distribute the exponent to each of them. Then, when exponent is negative on the top, move to the bottom, make it positive. I have 3 raised to positive 3, x raised to positive 3, y raised to positive 3. When exponent is negative on the top, bring to the bottom, make it positive. And same thing here. When exponent is negative on the top, bring to the bottom, make it positive. When exponent is negative on the bottom, bring to the top, make it positive. So I bring 9 raised to negative 2 to the bottom, become 9 raised to positive 2. I bring x raised to negative 4 to the bottom, make it x raised to positive 4. I bring y raised to negative 6 to the top, make it y raised to positive 6. Then we multiply the top to the top, bottom to the bottom. On the top, 3 raised to power 3 is 27. I have 27 y to the power 6. On the bottom, 9 squared means 9 times 9, which is 81. Then on the bottom, x to the power 3 times x to the power 4. When we multiply two numbers with the same base, keeping the base and the exponent, 3 plus 4 is 7. y to the power 3 stays the same. Then simplify. Observe the number first. 27 and 8 and 81. I can first of all divide both numbers by 9. 27 divided by 9 is 3. 81 divided by 9 is 9. Then again I can divide both numbers by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. I get 1 over 3. Then for x, there's no x on the top and the bottom, so there's nothing I can do. I leave it the way it is. It cannot be simplified. For letter y, we have y on the top and the bottom. I can try to simplify y. They have same base. The top has larger exponent. The top has larger exponent, so I keep y on the top. Use top exponent on the top minus exponent on the bottom. 6 minus 3 is 3. Use the larger minus smaller. 6 minus 3 is 3. For the final answer, 1 times y cubed is y cubed over 3x to the power of 7. And that's the answer. Next, 2x y squared raised to power 3 times 3y over x squared raised to negative 2. 2x over y squared raised to power 3 times 3y over x squared raised to power of negative 2. So when there's a power outside the parentheses, we distribute the power first. We have 2 raised to power 3 x raised to power 3 over y raised to power of 6. Distribute exponent to each of them inside the parentheses. Next, same thing. When there's exponent outside the parentheses, distribute exponent to each expression in the parentheses. We have 3 raised to negative 2, y raised to negative 2, x raised to negative 4. Negative 2 times 2 is negative 4. Then, when the exponent is negative on the top, bring to the bottom. When the exponent is negative on the bottom, bring to the top. So I have 3 raised to power 2, y raised to power 2, x raised to power 4. When the exponent is negative on the top, bring to the bottom, make it positive. When the exponent is negative on the bottom, bring to the top, make it positive. The first part stays the same. Since everything is positive, all exponents are positive, it stays the same. Then we multiply the top to the top, bottom to the bottom. On the top, 2 to the power 3 is 8. X to the power 3 times x to the power 4. When we multiply two numbers with the same base, keep the base and the exponent. 3 plus 4 is 7. On the bottom, 3 squared is 9. Y to the power 6 times y to the power 2. When we multiply two numbers with the same base, keep the base and the exponent. 6 plus 2 is 8. So that's the final answer. They cannot be simplified. We have base x on the top, base y on the bottom. Since they have different bases, they cannot be simplified. So that's the final answer. Next, we will study polynomials. Let me first of all introduce what is a polynomial. A polynomial is an algebraic expression with one or more terms. A polynomial is an algebraic expression with one or more terms. Where each term must be a number a variable or a number with variables raised to positive integer power. A number with variables raised to positive integer power. Let me show you some example about polynomials. What's called polynomial? For example, it could be 2 times x, a number times a variable. It could be 5x squared minus 7y. This is polynomial with 2 terms, where each term is a number times a variable, raised to positive power. It could be negative 3 m squared n plus a half y to the positive 4 minus 4 a b c cube. That's a polynomial with 3 terms, where each term is a number times variable raised to positive power. Number times variables raised to positive power. Numbers times variables raised to positive integer powers. Or it could be negative 6 minus 7m plus an minus 3mn. This is a polynomial with 4 terms. First term is a number. Second term is a number with a variable. Third term is a number with a variable. Fourth term is also a number with 2 variables. So they are all called polynomials. For polynomial, the exponent must be positive integer. The exponent, if there is exponent, exponent must be positive integer. So they are all called polynomial. This is a polynomial with 1 term. This is a polynomial with 1 term. This is a polynomial with 2 terms. This is a polynomial with 2 terms. This is a polynomial with 3 terms. 1, 2, 3. This is a polynomial with 3 terms. This is a polynomial with 4 terms. For polynomial with 1 term, there's a special name. It's called monomial. For polynomial with 1 term, it's called monomial. Monomial represents polynomial with only 1 term. If a polynomial has 2 terms, it's called binomial. If a polynomial has 2 terms, it's called a binomial. If a polynomial has 3 terms, it's called a trinomial. For polynomial with 4 or more terms, there are no special names. We just call them polynomial. For polynomial with 4 or more terms, there are no special names. We just call them polynomial. Let me show you some example of non-polynomials. Two x raised to -1. This is not a polynomial because exponent is negative. Or because it has negative exponent, same thing. Exponent is negative. And because it has negative exponent. This is not a polynomial because it has negative exponent. 3x squared plus 6x raised to a half. This is not exponent. This is not a polynomial. First term is okay, but in the second term, the exponent has fraction. The exponent must be positive integer for any polynomial. Exponent must be positive integer. And this exponent here is a fraction. So this is not polynomial because it has fraction polynomial, fraction exponent. This is not polynomial because it has fraction exponent. Next. Seven over x plus 3. This is not a polynomial because polynomial must be variable, a number times a variable. It cannot be variable. It cannot be a number divided by a variable. This is not polynomial. Polynomial must be in multiplication form, but this is in division form. This is not polynomial because we have variables in the denominator. This is not polynomial. Polynomial must be numbers times variable. It cannot have variable in the denominator. This is not polynomial. Also, cube root of x plus 2y. Again, this is not polynomial because it contains roots. Because variable is under a root. Let's call a cube root. A variable under a root is not a polynomial. So those are examples of non-polynomial. Exponent cannot be negative. Exponent must be whole number. Exponent must be positive whole number. Variable cannot be on the denominator. Variable cannot be under a square root or any root, cube root, fourth root, fifth root. Variable cannot be under a root. Next, let me introduce some basic concept about polynomials. A polynomial has a leading term. The leading term of a polynomial is the term in the polynomial with the highest degree. The leading term of a polynomial is the term in the polynomial with the highest degree. Leading coefficient the leading coefficient of a polynomial the leading coefficient of a polynomial is the number in front of the leading term. Constant term. The term in a polynomial with no variables is called the constant term. Now let me show you an example about what does this means. Let me show you some example. Look at this example here. 2x raised to power 4 plus 3x raised to power 3 plus 4x squared minus 7. So the leading term is the term with the highest degree. What does degree means? In the first term, x raised to power 4, degree is 4. The first term has degree 4. Second term has degree 3. We have power 3 here. Third term has degree of 2. Last term, if there's no x, we say the degree is 0. If there's no x, we say in the last term, degree is 0. So the leading term here leading term is 2x to the power 4. Leading term is the term with the highest degree. Leading term is the term with the highest degree. The first term has degree 4, so that's the term with the highest degree. That's called leading term. Leading coefficient. Leading coefficient is the number in front of the leading term. Leading term is 2x to the power 4. Leading coefficient is a number in front of the leading term, which is 2. The constant term. Constant term is the term that has no variables. Number 7 is a term that has no variable. For constant term, it's -7. We must carry the sign. So -7 is the constant term. That's the term with no variable. This is the constant term. We must carry negative sign. You cannot take 7. You must carry negative sign. Treat this as -7. You must carry -7. This is the constant term. Another example. 7x minus x cubed plus x squared. 7x, that's the term of degree 1. If there's no power, we assume the power is 1. So 7x is the term of degree 1. S cubed, that's the term of degree 3. Because power is 3. X squared, that's a term of degree 2. Because power is 2. What's the leading term here? Leading term is not the first term. Be very, very careful. Leading term is not the first term. Leading term is the term that has highest degree. Leading term is the term that has highest degree. The term of highest degree is degree 3. Negative x to the power 3. We must carry the sign in the front. We must carry the negative sign in the front. Leading term is negative x to the power of 3. What's the leading coefficient? Leading coefficient is a number in front of the term, but if there's no number in the front, we assume there's a number 1 in the front. If there's no number in the front, we assume there's a number 1 in the front. So the number in front of the term is, the number in front of the leading term is negative 1. That's the leading coefficient. The number in front of the leading term is negative 1. That's the leading coefficient. How about a constant term? Constant term is the term that with no variable. Constant term is a term that has no variable. Constant term is the term that has no variable. So every term has a variable. So we assume the constant term is 0. If it does not exist, we assume the constant term is 0. If every term has a variable, the constant term is 0. If it does not exist, we assume the constant term is 0. Next. Descending order. What does descending order means? We say a polynomial is in descending order of x if the degree of x decreases from left to right. We say a polynomial is in descending order of x if the exponent of x or in a sense degree of x, if the exponent of x decreases from left to right. We say a polynomial is in descending order if the exponent of x decreases from left to right. For example, in our first example, the degree of x decreases from left to right. Power 4, power 3, power 1, power 0. The degree of x decreases from left to right. So this polynomial is in descending order. And this polynomial is not in descending order because the degree is not decreased from left to right. Power 1, power 3, power 2. This is not in descending order because the degree is not decreases from left to right. Example. Rewrite each of the following polynomials in descending order. Rewrite each of the following polynomials in descending order. 2x minus x to the power 4 plus 9. So first term has degree 1, second term has degree 4, third term has degree 0. If I try to put it in descending order, I want a term with the highest power come first. So I want the term with x to the power 4 come first. I write it as negative x to the power 4, and this term has degree 1. It comes after power 4. Last term has degree 0. It's the last. This term has degree 1. This term has degree 4. This term has degree 0. So we want a term with highest degree come first. The term with higher degree come first. Degree 4, degree 1, degree 0. Next. 2x squared minus 3x to the power 3 plus 5 minus 4x. So in descending order, we want a term with highest power come first. The term with higher power come first. This term has power 3. This term has power 2. This term has power 1. This term has power 0. So we want negative 3x to the power 3 come first. This term has degree 3. First term here has degree 2. Last term has degree 1. And number 5 is a term that has degree 0. Number 5 is a term that has degree 0. That's polynomial in descending order. Next, let's try a few more examples about polynomials. Evaluate each of the following polynomials. First one, 3x to the power 4 minus 2x plus 5, where x equal to 2. Evaluate the first polynomial, 3x to the power 4 minus 2x plus 5, where x is 2. So when we try to evaluate a polynomial, substitute 2 for x, substitute 2 for each x. We have 3 times 2 to the power 4 minus 2 times 2 plus 5. Then follow pandas. We do the exponent first. 2 to the power 4. That means 2 times 2 times 2 times 2. There are 4 2's multiplied together. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. Do exponent first. Then we do multiplication. 3 times 16 is 48. 2 times 2 is 4. Then we have addition, subtraction, work from left to right. Addition, subtraction has same priority, work from left to right. 48 minus 4 is 44. 44 plus 5 is 49. That's the answer. number 2. 2x to the power 3 plus 4, where x equal to negative 3. 2x to the power 3 plus 4, and x equal to negative 3. So when we try to evaluate a polynomial, we plug in negative 3 for x. We have 2 times negative 3 raised to power 3 plus 4. Do exponent first. Negative 3 raised to power 3, it means negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3. When we multiply two numbers with different sign, answer is negative. 9 times 3 is 27. So when I multiply negative 3 raised to power 3 is negative 27. Positive 2 times negative 27. When we multiply two numbers with different sign, answer is negative. 2 times 27 is 54. Now we have negative 54 plus 4. When we add in two numbers with different sign, keep the sign from the number that has larger magnitude. Then subtract the magnitude. 54 minus 4 is 50. Next, 2xy plus 3x squared minus 4y squared, where x equal to negative 1 and y equal to 3. 2xy plus 3x squared minus 4y squared, where x is negative 1 and y is positive 3. So when we try to evaluate a polynomial, I substitute negative 1 for x. I substitute 3 for y. I have 2 times negative 1 times 3. I substitute negative 1 for x. Substitute 3 for y. Then do exponent first. Follow pandas here. We do exponent first. Negative 1 squared means negative 1 times negative 1, which is positive 1. 3 squared means 3 times 3, that's 9. Next, we do multiplication. 2 times negative 1 is negative 2. Negative 2 times 3 is negative 6. 3 times 1 is 3. 4 times 9 is 36. Then we have addition and subtraction. Work from left to right. Negative 6 plus 3. When we add in two numbers with different sign, keep the sign from the number that has larger magnitude. Negative 6 has larger magnitude, so I keep negative sign. Then subtract the magnitude. 6 minus 3 is 3. Leave negative 36 the same. Then again, consider we combining like terms. Negative 3 plus negative 36. Negative 3 plus negative 36. When we are adding two numbers with the same sign, keep the sign, add the magnitude. 3 plus 36 is 39. And that's an answer.